Good evening. We are.
Good evening.
Yeah, good evening, people. We are continuing with our training. Okay. So last time we ended at module 8, address resolution protocol. Okay. So the main objective of this module is to analyze address resolution protocol data units on a network, the PDUs. Okay, so we're looking at the MAC address. Okay, this is a media access control address and the IP address. Okay, so the MAC address is also called the physical address or the hardware address, because each and every laptop has this unique address. And then we have the IP address, which is the logical address. Okay, so now we're looking at destination on same network. That is, you are sending something on the same network. For example, if you see here, this is PCA sending something to the server on the same network. Okay, so here, since we are on the same network, you remember we looked at the structure of a frame. So what we must have in the frame, is information such as the destination MAC address will be the MAC address of this server, as you can see here, 0000B. And then the source will be the source MAC address of A, which is 00A. So you see, devices that are communicating on the same network, they use the MAC addresses to communicate. Okay? So as I said, the MAC address is also called the physical address. Okay? Used for Ethernet NIC to Ethernet NIC communication on the same network. So this is network interface card. Okay? From one network interface card to the other network interface card. You see where you press the cable there, the network cable, what you have there is a network interface card. Logical address, this is the IP address. Okay, it is used to send the packet from the source, from the original source to the final destination. Of course, this is when we are moving information to another network. When we're moving information to another network, we need to involve the IP address. Okay. All right. So here, you see, destination on remote network. So this is the topology. The topology is how the devices are connected. Very, very important that you know the language that is used in certain, subjects, like in networking. Topology is how the networking devices are connected. So once you know these terms, even the course itself becomes easy. So what we have here is PCA, this is the router 1, router 2, and this is the server, okay? What is happening is when you see the router, it means that we are dealing with 2 separate networks. So we have got this network here, and we have got this network here. When you want to connect 2 separate local area networks, what we use is the router. So in our case, the destination address here becomes the destination address of this router, okay? As you can see, 00C, you know. The source MAC address remains the same, which is this one. The source IP remains the same, and the destination remains the same. So here, what you need to take note is that when we are moving data to a remote location, the destination MAC address will be the MAC address of the router, okay? So this is the device we use to go to another network. ARP, this is address resolution protocol. Okay, now, what is the concept or the idea behind ARP? Okay, so this is a local area network, and this is a switch. We use the switch to connect computers. Okay, so since this is a local area network, for these devices to communicate, they use MAC addresses. So we can have a situation where H1 wants to send something to H4, but in its table, it only knows the IP of H4 and not the MAC address. So now, how is H1 going to know the MAC address of H4? H1 will send a message called an ARP request, okay? And this is going to be a broadcast, you know? What type of a message is a broadcast? Okay, a broadcast is a type of a message which is going to reach all the devices in this network. Okay, so it will send an ARP request. Okay, this device will open up the message and compare the IP address in the message with its IP address. If they do not match, H3 will drop the message. But again, the same message will reach H4. H4 will open the message, compare the IP address in the message with its IP address. If they do match, then H4 knows that the message has been directed to it. Therefore, H4 is going to reply with an ARP reply. And in that reply, it is going to include its MAC address. Okay? So H1 will receive that message and it will put in its ARP table the IP address and the MAC address for H4. That is then now H1 will be able to send the message to H4 after learning its MAC address. So that process, you know, is called an ARP, Address Resolution Protocol. Okay, so that's what is being explained there. You see, there are also some videos here that you can watch on ARP. Okay, so you find that on a PC, the ARP entries will be kept for a certain period of time. If they are not used, then the PC will flush them out. Okay, that's how it works. Okay, so the timers differ depending on the operating system of the device. That is, the flushing out of the ARP table differs, it depends upon the operating system of the device. And also, commands can be used to manually remove the entries from the ARP table. Okay, so on your laptop, if you want to see this ARP table, you go to your command prompt and type, anyway, so this is for the router, but for your PC, this is the command, ARP --A. So what you see here are IP addresses being matched to MAC addresses, and how these were learned. Was it dynamically, automatically, or was it statically, manually? Okay, so this is an ARP table. You can see it on your laptop. Just go to the command prompt and type ARP --A. On a router, okay, how do you see how do you see this table? Okay, you go to what is known as the privileged mode. Okay, and then you key in the command show IP ARP. Okay, so you'll be shown the protocol, the addresses. You see, this is the aging time I was talking about. This is the MAC address, and this is the interface. Okay. All right, so this is the lab we are going to do. We are going to use the Wireshark to examine the frames. ARP issues. What are some of the issues? So, due to the fact that ARP send ARP broadcast, then this can lead to ARP broadcasts and what is known as ARP spoofing, okay, or ARP flooding. So the thing is, we are going to have a situation where more than one device will send a broadcast. More than one. Okay? So that is going to consume the bandwidth, and of course, it is going to make the network to be slower. Okay? Apart from that, with ARP spoofing, you find that the hacker somehow can be connected to this network. Okay? He receives the ARP request, and then he can pretend to be the default gateway, falsifying the IP address of the default gateway. Okay, so this is what I was talking about, ARP spoofing, potential security risk, whereby if the hacker has got access and these PCs are sending ARP requests, ARP broadcasts, you can be able to capture that information, manipulate that information, and feeding these with fake information that he is the default gateway, meaning all the traffic has to pass through him. Okay, all right. So that is that on this lecture. Do we have questions before we proceed? Okay, anyway, let us proceed. Okay, we'll move on to Module 9, the transport layer. Okay, so the main objective here is to explain transport layer protocols support network what? Functionality. So what are some of the characteristics of the transport layer? Okay. So of course, the main responsibility of the transport layer is for logical communication, okay, between applications running on different hosts, on different computers, you know, applications running on different computers to ensure communication, you know, among them. Now, so this same transport layer has no knowledge of the destination host type, the type of the media which is being used. The transport layer doesn't know whether it's airwaves, it is fiber optic, okay? The path taken by data, the congestion on the link or the size of the network. The transport layer has no knowledge on these. The transport layer has two protocols: transmission control protocol and user datagram protocol. Okay, we are going to look at these, you know, as we go. The transport layer has so many responsibilities. The first one is tracking individual conversations. So what happens here is like this. When you open instant messaging, a source port number is going to be generated randomly, okay? And then it goes to where it wants to go. For the web page, again, a source port number is going to be generated randomly, and it goes where it wants to go. But when coming back, that information which went from instant messaging has to come back to the source port number, okay? And that one which came from web pages, you know, has to come back to the web pages because of that source port number which was generated, okay? So you can see here that, you know, the transport layer is able to track individual conversation. The other responsibility is segmenting data and reassembling the segments. Okay, so the transport layer is able to divide data into smaller segments. Now, you find that information on the internet uses different parts, okay? So we can have, for example, the segments in this order: 1, 2, 3, 4, 5, and 6. But when this information reaches the destination, it can reach in a different order. Let's say 6, 5, 1, and so on. So it is the responsibility of the transport layer to reassemble the data, to put it in the order it was. Okay, and the protocol which does that is TCP. Okay, all right. Okay, apart from that, the adding of the header, okay? So we looked at the OSI model and the TCP IP model, where when you are sending something, we move from the application layer, we are going down. So what we have in the application layer is just data. When that data reaches the transport layer, we are going to add the transport header to that information, okay? That process of adding the header is called encapsulation. Now, what are we adding? What we are adding are the source and destination port numbers, okay? All right. Okay, so the other responsibility, of course, is identifying the what? Identifying the applications we are dealing with through the use of port numbers, okay? So you can see port 110, it means we're dealing with an electronic email. Port 80, it means we're dealing with HTTP pages, okay? Port 531, it means we're dealing with an internet chat. Okay. All right. Conversation multiplexing. Okay, so this is also another responsibility whereby, of course, with multiplexing, we have information coming from a number of applications. You know, traffic coming from a number of applications and being put on the same link. Okay, being divided accordingly, you know, that is multiplexing. Okay. All right. So, you know, we have the application layer here. This is the transport layer here, where we have got two protocols, TCP and what? And UDP. You see, when we reach the internet layer, then we have the IP protocol there. Okay. Now, the transmission control protocol is reliable. Why? Because when you are sending something through TCP, if you are going to lose certain packets, those packets, they have to be resent. Okay, that is being reliable. Okay, and when you are sending something, if it has reached its destination, you must also receive acknowledgements. Okay, so those are some of the properties with TCP. Okay, so there is retransmission of data. There are some acknowledgements that have to be sent. So when you send something and you do not receive any acknowledgements, it means that TCP has to resend, okay? And to do that, of course, TCP involves the use of numbering, the sequencing, and so on. Okay. All right. So TCP is also called connection-oriented, meaning a connection has to be established. That is between this gentleman here, between the PC here, and the server. How is the communication established? It is established through a three-way handshake. Okay? So first of all, this PC will send a SYN message. And then the server will reply with a SYNACK. Then this will reply with an acknowledgement. And then they'll start exchanging information. That is what is called connection-oriented. Okay? Connection-oriented. Now, to do all that what TCP can do, it requires sequence numbers. It requires acknowledgement numbers, So this is the TCP header that you see. It must have the source port, destination port, sequence number, acknowledgement number, header length. This one is reserved. And then here we have got some control bits like finish, reset, okay, and others. This is windowing, which is used when you are sending data. That is, at what rate are you supposed to transmit data? The checksum used to check the errors in the header, TCP header, and then agent used if the header, is urgent, and then this one is optional. Okay, so the overall size for the TCP header is 20 bytes. Okay, so we will be able to see all these in the lab. Okay, all right. UDP is simpler than TCP. It is not reliable, meaning that there are no acknowledgements with UDP. So when you're sending an email, okay, when you are downloading a file, what you use there is TCP. Okay, when you're sending an email, because imagine if you're sending an email and you lose some of the packets, it means you're going to receive an incomplete what? Email message. So TCP makes sure that those packets that you have lost, they have to be resent. Now with UDP, it doesn't do that. No acknowledgements, no resend. Because of that, it doesn't have a number of mechanisms to ensure that there is acknowledgements, there is sequencing. Therefore, it is simple. Okay? It is simple. I don't know why they didn't put it here. Again, you see, with UDP, it does not resemble the packets like TCP. The way they have been received by the receiver, the receiver has the capacity to read that information in that order. Okay? So when we are streaming, when we are using IP phone, voice, those use UDP, because UDP is faster. UDP has got no acknowledgements. So if UDP had acknowledgements, then the streaming would have been slower. Conversation would have been boring on the phone because the packets have to be resent and so on and so forth. So when we are streaming, even though we lose some packets, we'll still be able to see. Or when we are using an IP phone, when we lose some packets, we'll still be able to get what someone is talking about. Okay. Again, you see, UDP is connectionless, meaning no connection is established. It doesn't have a three-way handshake like TCP. Okay. All right. Okay, so where do we use UDP? So they say UDP is best effort delivery, meaning it has got no acknowledgements. Okay. The sender of the letter is not aware of the availability of the receiver to receive the letter. So here we are sending something. We do not know whether the receiver is there or not with UDP because it is not connection oriented. There's no three-way handshake because with a three-way handshake, it confirms that there is a receiver. But with connectionless, we do not know what we have on the other end we just send. So you can see here, this is the header of UDP, very, very small, source port, destination port, the length of the header, checksum to check for errors in the header. You can see the size is 8. So this is smaller. UDP has a lower overhead, therefore it is faster. That's why it is used in streaming and so on. A socket, what is a socket? A socket is when you combine source IP address and source port number, or when you combine destination IP address and destination port number. We call that a socket. Okay, so we are looking at communication here. We have the source, the PC. This is the destination. Okay, now if it's FTP, have you seen it? FTP is port 21, is the destination port. The source port is generated randomly, you know. That's why there's no need for you to master the source port, but you have to master the destination port number 21. So when you see port 21, it means that FTP services are running on that machine. That's how even hackers know the services that are there, and then they go further and find out what are some of the vulnerabilities that they can exploit. So you see, web, destination port has to be 80. This is the source port number, which is generated randomly. Okay. All right. Transport layer session establishment. Okay. So this talks about the TCP server process, where first of all, you know, the client has to send the request to the server. First of all, it's a three-way handshake. Okay, after the three-way handshake, then the communication has to start between the server and the client. When that is done, the client will send the FIN packet to the server. Okay, and then the server will send the FIN acknowledgement. And then that's how the conversation is going to end. Okay. Okay, so that is what is being explained here. Okay, so this is the three-way handshake. I've explained about this, where, you know, the sender will send the SYN packet, then the receiver SYNAC, the receiver SYNAC, and then the sender will send an acknowledgement, and then these two pieces will now start exchanging information. Once that is done, then the FIN packet has to be sent by the receiver. So this is what happens. Okay. So I've talked about the three-way handshake. What are some of the control bytes that are there? You know, we have urgent, that is if the segment is urgent, acknowledgement, okay, pushing, resetting the connection. This is for synchronization, and this is for ending the conversation. Okay, so we are going to have this lab where we are going to observe the three-way handshake using Wireshark. Okay, transport layer reliability. Okay, so I've talked about this already, saying TCP is reliable because of the acknowledgements And when we lose some data, we have to resend. And then ordered delivery is this. You are sending information from this PC to this PC. This is the internet. This is the order in which the segment were sent. But due to issues on the internet, you find that these segments can use different parts, and they will reach in this order, in an ordered way. You see, obviously, this is 1, 2, 6, 5, 4, and 3. TCP has to reorder these for this PC to understand the message that it has received. Okay. So I've explained on data loss and retransmission already. Okay. So there is the numbering, okay, which goes on. All right. So you see here we have sent segment 1, segment 2. 3 and 4 have been lost. Okay. 5 has been received. All right. So then TCP will make it in such a way that these, they have to be resent later. Okay. That's how it happens. Okay. Window size and acknowledgements. So I think, you know, you have downloaded stuff at one time. And at first, you know, when you start downloading, they will show the time 2 hours. But later on, you see 30 minutes. Why? It's because of the window size. Okay? But before I talk of the window size, let me talk about flow control. With flow control, this is when you have got 2 devices. You know? So the other one is sending information at a faster rate that the other cannot cope. Therefore, it will send a message to the sender telling him to relax. We call that flow control, okay? And TCP do that, okay? With the window size depends on these 2 agreeing on the amount of data that has to be sent, okay? So they can say, anyway, we'll start with 10,000 segments, okay? But later on, looking at the reliability of the link, they can increase the window to 14,000. That's why you see that when you're downloading something, you know, they will say 1 hour, but later on, 30 seconds. It's because of the change in size of the window. Okay. All right. The maximum segment size. So the maximum segment size for IPv4, it's 1,460 bytes when we're using IPv4. Okay. No. Yeah. But the MTU, okay, which is the maximum transmission unit, is 1,500 bytes. So you find that if it is less than this, the device is going to drop it. If it's more, the device has to drop that as well. Okay. All right. So that is that on the transport layer. Okay. So TCP also has a way of avoiding congestion. Okay. So when we have congestion in a network, you find that some packets can be dropped. Okay. So when packets containing TCP segments don't reach their destination, they are left unacknowledgements. By determining the rate at which TCP segments are sent but not acknowledged, the source can assume a certain level of network congestion. Whenever there's a congestion, retransmission of lost TCP segments from the source will occur. If the retransmission is not properly controlled, the additional retransmission of TCP segment can make the congestion even worse. Okay. So to avoid and control congestion, TCP employs several congestion handling mechanisms, timers, as well as the algorithms that it uses. Okay. Right. From there, we now go to what we use, what are known as network services. I told you that this is the longest, it used to be the longest chapter, but it was divided into modules so that at least people can relax. You know, sometimes when you are reading something which is long, you know, you tend to lose focus somehow. That's why it was divided into modules. So the objective here is to explain how network services enable network functionality. Okay, what do we have? DHCP, Dynamic Host Configuration Protocol. This is the protocol which is used in your organization to assign IP addresses to the computers automatically. So this DHCP, if your organization is very big, you can have your own DHCP server. But if it is smaller, then such a service, you can get it from the internet The internet service provider, okay? How you assign addresses to computers is done in two ways. Automatically, which is dynamically, using DHCP, or statically. The network admin enters one by one manually. But of course, imagine if you have got 1,000 computers, you know, then that's a difficult job for the network admin. And, you know, he's human, therefore is bound to errors. So very, very important that you just implement DHCP. Okay, so what happens when you go to, you know, a hotspot with your laptop? Here is your laptop. So your laptop has to look for the DHCP server. It will send a message called the DHCP discover. This message is a broadcast because it has to look for a number of DHCP servers. Then one of the DHCP server will reply with the DHCP offer, offering your laptop the IP address and the MAC address and the default gateway to use, okay? And then your laptop is going to send the DHCP request. So this has to be a unicast because it's coming from a server going to your laptop. But the DHCP request has to be a broadcast because it has to go to a number of DHCP servers telling them that you guys, I have been given an IP address, okay? Then that DHCP server which offered you the address will reply with the DHCP ARC. That's how it works. So, you know, you are offered this address to be used only for a certain period of time. Okay? So 50% of the time remaining before your time, before before the use of that address elapse, you have to send another request to the DHCP server to extend the length. Okay? Then you find that in some cases, the DHCP server is not replying. And when you are remaining with about 12.5% of the time, you'll be forced now to look for another DHCP server. Okay. All right. So the DHCP message format, it has the operation code, okay, the hardware type which is involved, okay, the hardware address length, the hops, the routers, transaction identifiers. So this is the server IP address, okay, and others. In fact, it has a number of components which are not even, included here, okay. The other service that is there is domain name system, okay. It is used to associate names with their IP addresses, okay. So what you need to type is just CISCO. So this message goes to the DNS server. The DNS server matches the word CISCO to the IP address. Then that's when the request now goes to CISCO, okay? So this DNS is a hierarchy. You have a number of servers. First, you have what are known as the root servers. And in the world, we only have 13 of them. 10 in the US, 1 in Japan, the other in the UK, the other one in Sweden, okay? So you have got top root level domains, and then followed by top level. This is where you have got .net, .com, and so on. Then you have got the second level domain, okay, and so on. So it is a hierarchy. If there's no information here, you request this server to ask from another server, and so on, okay? So this is what I was explaining. You request for this, for the information from this server. If it doesn't have, it will move on to another server, and finally to the root server, okay? That is what happens. Anyway, it's just the process explaining the same. What are some of the components of the DNS message format? So you can see DNS uses UDP. So you have the UDP header here. Okay, the DNS fixed header, the question section, answer section, authority section, as well as some additional information section there. Okay. All right. Okay, so when changes were made to the domain, everything used to be done manually, but that wasn't good. Therefore, dynamic DNS was introduced, okay, to automate the process. Okay. Who is? So the who is, this is very, very important. And this is what hackers use when they want to dig information about your organization. They go to who is to know a lot about who owns the domain and so on. Okay. NAT. So this is network address translation. So the idea here is that we were running out of IPv4 addresses. Therefore, they came up with private addresses. These private addresses can be used by a number of organizations, the same addresses. But you can't use the very addresses to connect to the internet. Okay? So you have the private addresses here, and you have to configure NAT on the router. That is, when configuring NAT, you can configure the NAT pool. And in the pool, that's where you put the public addresses. So the PC with a private address, it will come and pick the public address and goes to the internet, okay? At least NAT increased a number of addresses in that a number of addresses could, that is, a number of the same addresses could be used by so many organizations. Okay, so that is the idea of NAT, all right? So what you see here, these are private addresses, okay? And you configure NAT here, all right? So when this PC wants to go to the internet, it is going to match this IP address to a public address, okay? And because of that, you find that the internal addresses here are not known to the internet, you know? So NAT somehow gives us security, but it is also a danger. For example, if a hacker has used a private address to hack your institution, it will really be difficult to track that hacker. Okay, so you can see here, this is how NAT works, and make sure you must know these terms. Inside local is the IP address of this device, okay? And then we have inside global, okay? Outside local, and global local is this very address of the server, okay? All right. Now, we have three types of NAT. There is static NAT, okay? So static NAT, we call it one-to-one. So static NAT is a situation where we want someone from the internet to access our server. So what we configure there is static NAT. Then we also have dynamic NAT. With dynamic NAT, in our organization, we can have private addresses. And on the router, we can configure a pool of addresses such that a PC comes, you know, it picks its public address and it goes to the internet. That is dynamic NAT. The third type is PAT, port address translation. So with port address translation, what happens here is we have these PCs inside our organization, and here we only have one public address, but we are going to use port numbers to differentiate the connections coming from these PCs. So if you can see, the public address here is 209.165.200.226. You see, this is the port number. And look, it's the same, 209.165.200.226. But the difference you can see is in the port number. This is what we call PAT, port address translation. Okay. File transfer and sharing services. Okay, so of course we use FTP In fact, we use secure FTP. Okay, trivial is not secure. And when we are using TCP, we have two connections that have to be established. The first one is control connection, followed by data connection, where the actual transmission of data has to occur. Apart from that, you can also use the server message block, to share the files. Okay. Email. I think I've talked about emails a number of times. When you are sending an email, the email that is involved is SMTP. And again, when the email is moving from one server to the other server, SMTP is also involved. Okay? But when you are receiving an email, the protocol that is involved is POP3. You can either use POP3 or IMAP. The difference between POP3 and IMAP is that when you receive an email through POP3, it means that that email will be deleted from the server. But when you receive an email using IMAP, it means that that email will still be on the server. Okay, I've explained that. Okay, HTTP, so this is for web services. And of course, the web page is made using the hypertext markup language. And this, of course, is associated with web address, or what we call the uniform resource locator. So this is the web address that we have. Okay, so the protocol here, of course, when you are browsing, is HTTP. So this is the server name. Okay, we have index.html. This is the specific file name that has to be requested by the client. So the client has to request for the page, and then the server will provide the page. And that is what you see in the end on your laptop. Okay. So of course, this is the HTTP URL. Okay. So what you have is the protocol first, followed by the domain. You see the port, the path, the query. What are you, requesting for? Okay. And then lastly, we have the fragments. So HTTP has a number of methods that it uses. Get methods, when you want to get something. Okay, posting, when you want to upload something. Okay, putting, delete, options, and so on. And the status codes, very, very important to know these status codes. That is when you're dealing with HTTP. Okay, so if you receive 100, you can see 1. It means that, you can continue. Okay, 200 is a success. It means that the request was completed successfully. 202, it means that it has been accepted. Okay, but 400, it means that there's a current error. I think you have seen 404, it means that there's a current error there. 500 with something, it means that there is a server error. Okay, so make sure you have to know these status codes. Okay, so have you seen 403 for forbidden? The request is understood by the server, but the resource will not be fulfilled. Have you seen 404? I think you have seen this. Information not found. Okay. All right. Okay. Okay, so that is that on network services. Okay. All right. Let me check. We still have a little bit of some time. We still have got about 15 minutes. I think for today, that is that. When we meet tomorrow, we'll start from here. Okay, so now we really, get back into business, writing chapter exams, doing the labs, getting the skills that you're supposed to get. Okay. I really thank you very much for attending. I will see you tomorrow.
Thank you.